What is a thread in programming? A thread, which is a short for thread of execution, is a smallest unit of processing that can be scheduled by an operating system. It is a sequence of programmed instructions that can be managed independently by a scheduler, which is also part of the operating system. Threads exist within a process. They share the process's resources such as memory and files, but can also be executed independently. Threads were first introduced in operating systems during the late 1960s and early 1970s, but they became more widely used with the rise of multi-threaded programming in the 1980s and 1990s. The concept of threading became standardized with programming languages like Java in 1995, thereby making threading a core feature in modern software development. Why should you use thread? Here are some of the reasons why you should use thread. You can use threads to enable concurrent execution of multiple parts of a program. Threads allow programs to perform multiple tasks simultaneously, thereby improving system performance and responsiveness. For instance, a web browser might load a web page while playing a video and downloading files, everything happening at the same time. Threads can help in the proper utilization of multi-core processors, improve user experience, and make efficient use of system resources. What are some of the advantages of threads? Now let's talk about the advantages of threads. Threads improve system performance, especially on multi-core systems where threads can truly run in parallel. Threads helps to make applications responsive, and this ensures that an app's UI doesn't freeze when doing background work. Threads reduce overhead by ensuring proper resource and memory sharing between threads within the same process. Threads also help to simplify code structure, as complex tasks can be broken into smaller logical flows. Threads creation process is very fast and efficient compared to when creating a new process. What are the disadvantages of threads? Now let's consider some of the disadvantages of threads. Thread management can be very complex, especially if we consider factors like synchronization, deadlock, and race conditions. Bugs related to concurrency are often very difficult to troubleshoot and fix. Too many threads can lead to high memory consumption. If not properly handled, data corruption can occur due to simultaneous access. Threads are used extensively in modern computing. It is highly used in a lot of real-world applications, such as in web browsers for handling multiple tabs, downloads, and rendering concurrently. In operating systems for managing background services, user interfaces, and hardware drivers. In game engines for running physics simulations, AI logics, and graphics rendering in parallel. In servers and networking for handling concurrent connections from clients, example HTTP servers. In scientific computing for performing large-scale simulations or data analysis in parallel. In mobile apps for keeping UI smooth while performing background tasks like fetching data. Now, why should you have a good knowledge of threads as a programmer? Having a strong understanding of threads as a software engineer is very essential, because it will help you to write faster and scalable programs by leveraging concurrency. It will also help you to follow modern software development practices, because most frameworks and libraries today are built with concurrency in mind. A good understanding of threads will help you to avoid problems like deadlocks, race conditions, and thread starvation. A good knowledge of threads can help you in your career growth, because a solid knowledge of multi-threading is expected in roles involving backend systems, game development, and high-performance computing. It will also help you become a good problem solver. This is mainly because concurrency bugs are tricky, so knowing how threads work makes you a better troubleshooter and problem solver. You can liken threads to cooks in a kitchen working together on different parts of the same meal. In this analogy, each cook represents a thread performing their own specific task, such as grinding pepper or baking bread. All these cooks work within the same restaurant, which represents the process. Just like threads, the cooks share resources such as ingredients, knives, and pots, which represent memory and system resources. Now, because they share these tools, they must coordinate themselves carefully to avoid conflict among themselves. For example, in situations where two cooks are trying to use the same knives at once. Now, to prevent chaos, the kitchen uses systems like locks or turn-taking rules, which is much like how threads use synchronization mechanisms such as semaphores to manage access to shared resources safely. If one cook is slow, it can delay the entire meal, just exactly like how a blocked or misbehaving thread can slow down or crash a program. And sometimes adding more cooks doesn't speed up the cooking process. In fact, too many cooks can lead to crowding and confusion, and this is very similar to how too many threads can cause high overhead due to context switching and resource contention. In summary, threading is a very powerful but complex tool, and it has a very steep learning curve, but it is definitely worth learning. If you want to become a pro in software engineering, I think you should consider mastering thread.